Should be making a video. So Hythloday left some comment indicating that I should have made a response to what he said in this video, and I don't know. I just didn't think he said anything explicit enough to require that. But so we'll play the second half of it and see if we can find something that. I mean, there are some subjects brought up, but I guess they're in such a loose fashion that I don't need to say anything. I mean, I don't know why he's bringing up Brownian motion in particular, just because I've been comparing the tension that electrons are in atoms to Brownian motion for like 7 years. I mean, that came up quite early in the conversation, that electrons are not in stable movers. But anyway.
That electron will be getting more collisions on one side than...
Yeah, it's true of everything in the universe. Technically, everything's getting buffeted, and it's probably has something to do with the initiation of gravity. Even the fact that something always makes a first move probabilistically towards something, and that first move initiates a response move, and and that's the whole point about induction, and how it feeds on one error, and that one error just keeps getting multiplied in a sense, however you want to call it, error, aberration, whatever. And so the whole thing is not made out of much of an initial spark kind of idea. The other thing that's interesting about the subject of the probability is the more permutations, the tinier the fluctuation becomes, right? So any irregularity becomes tinier and tinier the more and more you get more and more density, more and more mass of permutations. And as you're getting to something that has a thinner and thinner permutations, like with flipping heads and tails, if I flip 1,000 coins, I'm only going to have a tiny variance compared to that 1,000. But if I just flip 6 times, I could quite easily have 4 to 2 or even 5 to 1. So I could have a huge lopsided circumstance. So I would sort of argue that this is the condition of electrons, in the sense that depending on their history, they could have very little to play with. So the higher their velocity in a direction this way, right, you could argue they have very few rowers this way, left to right, because most of their rowers are doing the forward thing. So the amount of deviance you could get in probabilistic terms, like if it was 3 and 3 on each side, your assassin, the external world, could kill the 3 on one side before it even hits 1 on the other side. So making the electron look like it's going right, when no, it's going to go back left eventually, but it's going right first, and then it's going to go left. So any balance can look like a huge imbalance in any one set of moments, and as soon as you extend those moments to the full probability, well, then it'll equal out eventually. But at any one moment, it could look quite irregular.
The other, and eventually it will slow down due to drag.
Yes, I've been saying this forever. I mean, for years I've been saying this, so I don't know this isn't news to me. I've been pointing out how electrons and protons, in my opinion, theoretically, can't have sustainable velocity. That's why I'm saying they don't make it here from outer space. The only thing that makes it here are these cosmic particles that are hydrogen nuclei. And then when they hit the magnetosphere and the atmosphere, they break into the smaller rays, the smaller components. And what are the smaller components? Well, they're also component parts, right? We know the muon, they're kind of speculating that it's maybe 2 electrons. It's not exactly it's something like an electron, but it's different somehow. And I would argue the difference is that, yes, it's a composite particle, not a single particle.
That's would be a claim of the electron model. And I think that would scale up to all scales where.
See, that's where it goes wrong, is that it doesn't scale up to all scales, because as I pointed out, we clearly know that if I throw this into outer space without any, substantial gravity to get in the way, it'll go for a hell of a long ways with, with that initial velocity. I won't have to do anything. So drag is obviously not a problem, a significant problem. Might be some problem because we can't really tell that, but it's not much of a problem. And so I've already pointed out quite clearly that the component parts can't do that. So obviously it has to do something with the composition of matter, in the sense of you need this minimum amount of stuff to be able to create a throwable. Okay, and I was sort of arguing that we sort of know what the minimum is because we see it coming from the environment. The only stuff that we get hit by are the photonic type energy or a clump of this nuclei crap. You can get this nuclei crap going pretty damn fast, and some of that stuff hits us, but it doesn't hit us personally because it breaks into pieces before it gets to us.
You have drag.
Right, a subject I have dealt with. The only reason why I'm being a little slow in making a bunch of drag videos is there's a subtlety to this whole red and black force thing. It comes down to, and it comes down to what gives things momentum versus what doesn't. It has to come down to the motion of the reflection, as pointed out. The reflection is really things changing seats, and likewise I have to, I have it. It's not like I don't have it. I just didn't want to present it in a imperfect way because people are so nitpicky, okay, that if I say something a little bit wrong, they're going to say, oh, blah, 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 all this harassment you get. So I thought, leaving it as just, I think I've already proved the concept. I think I've proved the concept that there's mechanisms that could exist inside of atoms where there actually is the perpetual motion of the rowers, the fact that they're always rowing, and the fact that you could have more rowers in a direction, that you're not violating conservation of energy to make the argument that there can be arrangements of matter where that's just the way it is. There's more rowers in one direction than there are in the other direction in the end. That's what it adds up to. And I think I pointed out with this force exchange argument that the electron can bend proton energy, and the proton can bend electron energy for free. There's no momentum exchange. The proton doesn't do anything. It's just allowing forces to interact, and it itself doesn't get any momentum. And as soon as you can make that 90-degree turn for free, that is without causing momentum in the opposite direction, that's it. That's the end of it. We've solved the problem. And the problem is solved because the matter isn't providing the energy. The energy is force on force. The matter is a conduit for forces interacting, and so the matter isn't a player. And by not being a player, you can create imbalances in momentum, meaning you can have more forces pushing your particles one way than pushing them the other way.
Now, Mindless Marbles, I think, made a comment. They've invented a new comment scheme. I've started noticing that you can click, when you click, you can actually see the conversation without going into the video, which is much better.
I don't know what you're clicking, but I don't see anything better, frankly. But anyway.
Reminds me of the distinction between magnetism and electrical forces. In classical mechanics, in orthodox mechanics, static electricity, static charge gives rise to the electric force, which, for example, you can rub a balloon and stick it on the wall, or you can rub a nylon rod, a drinking straw.
Right. These all have to do with things to ground. So as soon as you create a circumstance where you're not always comparing it to a low pressure, right, where you're sticking something on low pressure, obviously you can't do the plus minus thing when everything's a minus. You're not seeing the whole story. because you could have the minus on the other side, or you can have two things that have the same charge. So you have to have something with an elevated charge for that to happen. So if you have in the environment, if we had in the environment a ground that was two kinds of ground, very high pressure and very low pressure, then you could make this argument, right? But grounds tend to be very low pressure. Low is, you know, pretty low, and so yeah, we don't have a way to let's see how to say it, but I think you're just wrong in the sense that you can't make the one charge. The ground is in the middle, right? So yeah, no. So I'm just saying that obviously everything's going to be attractive because you're moving away from ground and you're always attaching to ground. So I'm just saying that if you create the exact opposites, like you rub something on the stick and then you use the rag versus, I mean, the thing that you took charge off of versus the thing you put charge on with, you know, then you could manipulate things with both repulsion and attraction. But I think it's just wrong to say there's no repulsion. It's there. It's just that you have to create it by creating two high pressures. Yeah. I mean, there's not going to be much repulsion at low pressure, right?
A comb, and you can deflect water, pick tiny pieces of fluff or toilet paper, tissue paper, will be attracted to this thing. You can't.
You can do both with water. You can repel it or attract it. So, again, I don't think you're right there. But that's a little more complicated because it's the ions of the atoms, so it matters on what the faucet, whatever's letting the water come out of it, depends on what its charge is.
By design, do some kind of alternative rubbing and ever make this phenomenon repulsive.
Yes, you can. So I'm just saying you're wrong on that. It's just easier to do it. It's easier to create the differential, right? And the differential is always going to be attractive, positive to negative. Okay, but you can create two positive charges. It's just that, again, to be repulsive by sort of definition, the whole point is that to manifest the repulsion, they still have to have manifesting some kind of, they have to be leaking the force in some sort of substantial way. They have to be charged. They have to be, you know. So I guess what am I trying to say? Maybe it's easier to apply a positive charge than it is to apply a negative charge. That might just be why we don't see it.
But it's kind of an experimental phenomenon to note this kind of sticky attraction. Now, in orthodox science, that's understood through the electric force and the existence of negative charges and positive charges. Now, magnetism in orthodox science is understood through those charges having spin.
Well, you say they understand something. I'm saying they don't understand shit. So, if their spin gave them some tremendous insight into function, then I could argue that maybe there's some reason to play with this. But they still have no idea how it creates this positive and negative. They have no idea how it makes a magnet work. They have, I see no utility in it. Okay, you can say they can sit there and use spin and describe, again, effects, but they're not really understanding it, because they can't really apply it anywhere else with any consistency. They can only describe things they can see. They're not describing things they don't see.
And if all those spins are aligned, you can get this magnetic effect wherein we have found phenomena where it's by design got a north and a south pole. And this is by virtue of the fact that spin is pointing. Yeah?
Well, as I pointed out, it's just silly. Just because I'll say it overtly, okay? Giving electrons magnetic moments is retarded. Atoms can have them, lots of things can have them. An electron can't have a magnetic moment. It's just nonsense, in my opinion. It's clearly a negative charge. It's not a dipole. I think it's just nonsense to say they're dipoles. They just don't demonstrate any dipolarity.
You can always have an axis of spin, and if all those axes are aligned,
and certainly I don't think photons spin. So I'm just saying, I just think it's a waste of time to get into this this subtle influence of spin, when, again, I'll just argue that I think the argument is more about the fact that if something is in motion, you've changed its You've changed the rowers. And so now you've changed the probability, and you've changed the magnitude of effects in terms of the imbalances that you can create left to right. That's all.
In some fundamental way in this argument, you get an explanation for why there's a north and a south, and why they ultimately it's kind of magical in the orthodox schema of quantum mechanics.
Right, exactly. They say it's a point particle, then they say it has no radius, then they say well, it can't have spin, but it does have spin, so we're just going to live with another duality that's, in another contradiction, and we're just going to accept contradictions. We don't care. The evidence isn't complete, clearly. The story isn't complete, but they've taken their rubber stamp and put complete on it. So I'm just saying, what are you going to say? I think it's wrong-headed. I don't think spin is what they think it is. I don't see how spin functionally could work as a mechanism. Again, it breaks quantum mechanics in so many ways because it's very hard to, you're really talking about a tiny Planck constant when you're quantizing a spin. Maybe it's there, but I'm just saying, yeah, that really gets kind of hard to follow because you do have to change all of these vectors, right? Spin requires you to change the vector of the matter constantly through the motion. So at a high rate of spin, I don't even know how you do those calculations. It'd be so deep. But clearly I'm the one arguing that there's a mechanism that can do that without loss. And clearly the universe is doing it without loss. Right? Theoretically, if I spun something in space and I didn't agitate the bearings at all and everything was quite perfect, it could spin an awful long time. Okay, so obviously it's not being dragged to a halt. So we're back to this argument again. Something's capable of doing an awful lot of momentum exchanges for free.
But nevertheless, it's an observed simple phenomenon that you experience and wonder of. And for most people all their life, how does magnets work? How does static charge and electricity work?
Yeah, and I'd argue their spin diagram doesn't do it for them because they still haven't figured out how it creates attraction and repulsion. And again, these people who say this stupid, the idea that you can spin mediums, you can spin something in a medium and get the medium to start dragging along with your spin and then create a tiny bit of pressure difference. It would create a tiny bit of attraction or a tiny bit of repulsion. Obviously, I think you might agree that's not how nature works, right? That is so preposterously inefficient at creating attraction and repulsion that the magnitude, the amount of energy you would have caught up in your spin mechanism would be a billion times greater than the amount of energy you're getting out of your attraction. And that's not what we see in magnetism. We see a really efficient process.
So those are the next problems as well.
So again, you're saying that the next problems are already videos I've done, okay? I have a theory of magnets, okay? So, what do you want me to say to you except, I've already done that one. I've been there and done that one. I've been there and done that one in case of kind of constructing a magnetic model of how the atoms work, where you don't have spins and orbits and all that crap. So, fine, you don't see it yet or something, okay? You're going to do this one piece at a time, fine, that's fine with me too. Okay, forced me to remake the videos again, okay. But I'm just saying, I have done it. I think quite thoroughly done it.
And I think this is where the going gets tough and why...
I don't think it gets tough. It gets tough, yeah. When you don't know the answer, it's tough. Once you know the answer, you say, shit, that's so obvious. So you can say it's tough. I don't think it's going to be so tough. I think we've isolated enough facts. Again, the elemental bits, they do experience drag. They don't have the capacity to make a motor. Okay, but the fact is they do have perpetual motion. So we know the force bits have perpetual motion. Well, maybe we can agree they have perpetual motion. And all you're saying is can matter apply that perpetual motion and create a machine that allows it to have movement, free in the sense that it's going to take advantage of the perpetual motion of the force bits and do that in a direction. And there's no reason it can't. As we're pointing out, all it really has to do is segregate force. It just has to segregate stuff going this way from stuff going that way. And that's what we see with the space shuttle. We see a bunch of force going that way, and we see the space shuttle go this way. And so now we're just arguing, can the space shuttle hold that force? And I'm arguing, sure it can. It has no obligation to give it up to the environment at all. It can just keep the imbalance and keep going. Once it creates the imbalance, we're just talking about keeping it. Where the electron can't keep the imbalance because it doesn't have a mechanism to do that. The environment takes it away. I'm saying all we have to do for matter is to say matter has a mechanism to shield itself from the external environment that wants to neutralize its momentum. So we're just saying, yes, can we create a shield? Sure.
Nobody pursues it because nobody's been able to get over those hurdles with a purely...
They've never even gotten that far. So again, you're saying they've never gotten over this hurdle. They haven't. They haven't got over the hurdle of we have to account for the energy for gravity, and then they certainly haven't even gotten close to the hurdle of how's a magnet work. So how can they get to the subject of drag when they don't even know what velocity is? They've never even contemplated the difference between bodies. That some bodies have perpetual motion and some bodies don't. They're different. And one thing isn't the same as the next thing, isn't the same as the next thing. There are actually elemental bits that have elemental function, and then there are more complex things that have elements of that elemental function that make them do things that the other things don't do. Again, you have the example of water right in front of you, right? I mean, you have 99% of materials, that contract when cooled, and then you have this one molecule. Oh, no, I'm breaking the rules. I'm going to expand when I cool. Yeah. That's physics.
Rule-based, procedural, particle model. So
obviously none of the conventional physics people for the last 200 years have cared to even try to create a particle model. They decided it's waves, they decided it's wooey crap, and none of them, except for Einstein, cared to make a mechanical system. So you're just really saying Einstein failed. And he did, okay? But he at least was the only guy on the right track.
You think where you're up?
I mean, ironically, right? I mean, he was on the right track when it came to quantum mechanics. Clearly, his spent space, in my opinion, is complete woo. So the woo he hated in quantum mechanics, in my opinion, wasn't any worse than the woo he created when it came to understanding velocity and inertia. So he completely fucked velocity and inertia and acceleration with his woo, and then he hated that quantum mechanics was screwing with this quantum word because they turned it into this wavy nonsense.
As well as, obviously, there's the Stern. I don't have any good sources of that. I've only seen the animations and the drawings and the theoretical explanations of what's going on. But that doesn't...
Yes, well, it does completely. It does. There's a stamp. This is a kind of a substantial limitation on what you can argue when you can't be sure what the actual experiment produces. So again, this is another thing. Did they actually do it with electrons? Well, if they actually did it with electrons, there should be a video of that somewhere. I mean, this gets a little silly, right? Because how can I dissect an experiment that I can't see what the actual results are, and what I'm being shown is what they theorized the outcomes would be if they actually did an experiment. It's just huge differences. So the only experiment I know of is silver atoms, and obviously atoms are complex things. They're certainly dipolar. So yeah, what the silver atom, we know that any conductive material creates reflexive magnetism. That is, if you expose it to a moving magnetic field or an uneven magnetic field, clearly it's going to react to it by creating a opposite and equal reaction. So we kind of know that's what the whole Lenz's law says. So as I already said this stuff, but I'm just saying. So that's where we can start this conversation. Is that, well, clearly atoms aren't monopoles of charge. So how can I draw conclusions about any kind of spin notions on an electron when the electron's still attached to a fucking atom? I mean, isn't that going a little far? You're gonna analyze an electron's behavior based on how it acts when it's still attached to an atom?
Not lendable to discussion, and discussing what they say has happened. And I think it's a relatively simple device that's been constructed, or claimed to be constructed. It's not as complex as the two-slit experiment, wherein, as you found out, they're...
Well, the unevenness of the field is a little bit complex. So I'm just saying it's not like it's uneven in a variable way, right? It's just uneven over time and linearly. So we don't, so yeah, balancing all those effects. Like I said, it's not like the field doesn't exist. It's just a warped field in the sense that you have a stronger north than you have south exposure theoretically. So yeah, it's a little bit difficult to analyze that.
They haven't really done that.
It's electromagnets usually, as I understand it. And so we have this whole thing about currents or frequencies or some other kind of thing that could be affecting it.
The experiment as they portray it. As I said, I still accept, I'm reluctant to believe they're so corrupt to have not done what they've said to have done. And I've read a lot of papers about the which way experiment, wherein what they really do is...
Yeah, I know. So you have lots of examples where they take a grain of reality and they turn it into a whole theory, and they start drawing lenses in space, and they start telling you what they're doing. And as I've pointed out, well, we know the lens can't possibly be shaped the way they're drawing it because gravity doesn't work that way, right? Gravity gets stronger in the middle, and regular lenses are bending the light on the edges more than they bend the light in the middle, and it's completely inverted. And so, I mean, you have plenty of evidence that you really can't trust them to do an animation that's reality, because we know that they just create, well, here's a black hole. Yeah, I made it in a blender. I swirled some crap in a blender and I made a black hole. This is the lensing image of a black hole. Yeah. I mean, how many people are literally fooled by that crap and think this is based on some sort of thing they actually saw in space? They never saw one of these things. But they'll show us what it looks like. Now, don't you think that's a little dangerous? I think it's a lot dangerous. I mean, they have that stupid asteroid. They have all these animated pictures. They don't know what it actually looks like.
Is agree that this experiment effectively tests that facet of a prediction of the hypothetical two-slit observed experiment. So, fairly short, nice, simple 10-minute video though, I think. No need to go much further than that.
Well, you kind of do if you want me to reply, just because I need something, the whole opening of the vague door of a subject and saying, you're unconvinced of this whole area of thought. All I'm really saying is all my obligation is to prove proof of concept. They don't even have a concept for magnetism. They don't even have that. They just have this word, virtual photon, there. They don't have an energy source, and they don't have a mechanism that could make the energy into attraction and repulsion. So they have neither one. I have both. And so I'm just saying, how far is this intense scrutiny? When does it just become kind of obnoxious? When, again, how much of this do I really have to do 100 years worth of development work to present you this perfectly finished product? I have to do it all? None of you can do any thinking on your own? I mean, I have to create the whole courseware? You can't just understand that, yes, that's a substantial proof of concept where they have nothing. They have gibberish and fancy words and silly symbols, but they have just absolutely nothing they can draw on a piece of paper and show me why two magnets attract or two magnets repel. Nothing. They can just draw the magnets. They can't draw a single friggin' force line of any kind whatsoever. They can't give you any notion of a possibility. Well, the angel jumps over here and she drives the magnet into the other magnet, because we all know angels are really bad drivers. I mean, they have nothing. So, see if there's any stupid comments. What's in the boxes, or do you know? Yes, same stupid one that was there from before. Alright, so I think I have dealt with this part of the subject. So I'll just give you the brief on drag. And again, this is draft physics, okay? I'm just not certain of every element of this explanation. So, as I've pointed out, when an electron and proton interact, they do a reciprocal thing to the environmental forces that interact with them. Okay, so the force is likewise of two flavors, electron force, you could say, and proton force. And the two objects will react to that force, okay, in opposite ways. So when the blue force hits the blue object, there's an exchange, which means this arrow stays in the thing and the thing gives up an arrow going out. So it's a reflection. Now, it isn't an actual reflection because it's an absorption of momentum and a release of momentum, which is actually a 2-for-1 deal, right? I mean, if it just gave up this arrow, that would create a tendency to move in this direction. But the fact that it also kept one going that direction kind of implies almost a 2 quanta exchange. So it's a substantial piece of momentum, 2 times momentum. And what we're basically arguing is that in this opposite reaction, it's going to be the 0 momentum to make up for the 2 that it got this way. But that's getting more complex than I want to. And then the red force will bounce off the red force and do exactly the same thing. Create an apparent reflection, but what it's really doing is creating a 2x momentum change. Alright. And now when the red force hits the electron, so you can sort of understand that as this happens between these two objects, the real point is, the reason why these two objects ends up attracted is all of the blue force that reflects, that comes off of the electron through reflections or traps or any other means, it all ends up going out perpendicularly. And all the red force that reflects off the proton ends up going out perpendicularly, some perpendicular dimension, the 2 perpendicular dimensions, and that's dictated by its previous condition. So I'm not saying that it comes out randomly. It probably does come out in the direction of momentum. But anyway, so you can understand that no force can ever get trapped between the two, and therefore they certainly can't be repulsive because there's no reflections between them. Where if there was 2 electrons, there'd be a ton of reflections between them, or 2 protons, a ton of reflections between them. So it allows the reflective energy to be dissipated. Okay. So the real question is this, in terms of this momentum argument. So you understand that the reflections create momentum, but then this perpendicular reaction. Okay, if I do it doesn't really matter. I guess it doesn't matter if I do a proton as an example or an electron. The idea would be is that force comes in, all right, and this will keep none of it. So you could argue that, okay, a force comes in and it does make an exchange, but it makes the exchange in here somewhere, okay, and it's going to make an exchange obviously with the red. So the red arrow is going to be, you know, reflecting. But before it reflects out, it actually hits, you know, another blue arrow. You can argue, I think, a blue one. But see, this is the part I'm just not sure of. So another field energy hits it, and there's an interaction, and what ends up happening is the direction of the red ends up, well, no, the blue arrow would be coming from this direction. So see, this is where you get into trouble. All right. So you have a red arrow going this way, created by a blue arrow that went in. And then another blue arrow is going to hit it this way from the field. before it leaves here, so to speak. And now the red arrow is going to take the blue arrow's direction. So the red arrow is going to go this way, and the blue arrow is going to go this way, the direction that the red arrow was going. And so this moved none. This changed. None of the seats changed here. All they did was there was two interactions. One of the interactions happened inside the boat. So it's like, yeah, you were making an exchange, changing who was sitting on one side of the boat, and before that exchange could jump out of the boat, another exchange was made that essentially nullified the exchange, and all you have is the outgoing forces that have replaced their identity. Something that went in this way, one color, okay, yeah, so the argument would be that this leaves this way and the red leaves this way, something like that. Yeah, so I have to, like I said, it's a little more, it's complicated, so I'm going to have to sit down and really go through this thoroughly. But the idea is, I'm just trying to say is that this is where you have a directional change in the force, but you have no change in the disposition of the matter because the changes happen inside the boat. And so you have force going in one way, and you have an interaction where the two forces essentially, what's going to happen in the end is just, it's going to be these two forces, and the thing that's going to happen is the one force is going to leave, the blue force is going to leave in the direction the red had, and the red force is going to leave in the direction the blue had. So that's the bottom line of the interaction. All right, now the consequence of that is, in something like a helium or hydrogen nucleus, helium, you have an arrangement of electrons and protons, and in the simplest form, you could argue it's much like the water molecule. It has a lopsidedness to it, okay? And so the argument could be made is that the reflexive energy from this electron, okay, the electron energy, the blue, goes into the proton and it comes out this way, 90 degrees. It makes the perpendicular exchange, and it's the non-momentum exchange. Again, it's the blue energy, and the blue energy comes out at a 90-degree difference, and what got exchanged was some red energy ended up going a new direction that you don't see. It doesn't have consequence. I mean, it has consequence if there's a proton over here, but it doesn't have any consequence to this immediate circumstance. So the idea would be is these two electrons, you could see how they could reflect this way quite obviously. Lots of reflecting energy possible. Ping pong ball bouncing back and forth. And the idea would be instead the ping pong ball is also bouncing from here to here. So, and the only place it's creating a reflection, an actual force impacts, is on the surface of the electron. So the only energy in this equation is this way and this way. If you add up these two vectors, you get this. So this whole mechanism has got this momentum because this didn't create any down momentum because the forces did the exchanging, not the boat. So the boat went this way and this way to create, a neutral amount of motion, plus and minus, to create this 90-degree turn. And the 90-degree turn didn't create any momentum in the boat. It just created a change in what forces left. And so this mechanism, you could understand, is like little jackhammers. The ping pong balls will keep hitting these in this direction, and there's no other velocity except in this direction. So this is a little perpetual motor. And that's what happens inside of atoms. When a material body is being accelerated, what's happening is those little arrangements, all the neutrons inside of nuclei are turning, and the neutron is a proton and an electron, essentially. And so the interior of the atom is turning into one of these little triangles, this way, V's. and it's pointing them all in the same direction. So instead of pointing this way and this way and this way and this way and this way, they all start to line up. And as they line up, you gain more and more velocity. You achieve velocity. So the accelerating process is orienting those. And once they're oriented and lined up, you have your velocity. Because you have more jackhammers pumping energy this way than some other way. And this system would be quite durable against any external influences. So it would clearly defeat, as you're in the process of acceleration, you're defeating drag. That's what sort of acceleration is overcoming the drag. And once you've overcome it with your motor just pushes you upstream. No one thinks that if I have a 3-mile-an-hour motor and I have a 2-mile-an-hour stream, that somehow my motor can't work, that it's going to get tired or worn out. No, if I can put gas in it, I can just keep going 1 mile an hour up the stream. So that's the mechanism that solves drag. And I think it fits the evidence in the fact that the things that do overcome drag aren't elemental beyond just the force bits. So if you take the force bits out, the matter bits that have velocity in space are things as big as this nucleus. They have to have these minimal components to create a wedge against drag. To put it simply, it's like a wedge against drag, except it's obviously an inverted wedge. Alright. But again, it's not a subject. Like I said, I think I have proved concept. The details, again, is it's subtle, and it's easy to make an error, and so that's why I'm a little apprehensive and just keep presenting the argument beyond the fact that I have presented this before and pointed out that that's all you need here. If I can make this right turn for free, then I can use the perpetual motion of force to overcome drag. And I think it's a perfectly rational, suitable, possible explanation. Alright. So, till the next time and such. And so forth and whatnot. Mostly.